So our main group metal cations that are formed from groups 1A, 2A, and 3A are going to be named by identifying the metal and then following the word by ion. So naming our cations is going to be very easy. So for potassium, we would just call this a potassium ion. For magnesium 2+, we'd call this a magnesium ion. For aluminum 3+, we'd call this an aluminum ion. For our transition metals, which can form more than one type of cation, two systems are going to be commonly used to name these ions. The old system we're not going to use in here, so you guys don't have to know the old naming system, but you should be aware that it's out there because some people might use the old naming system. And it's good to know that it exists so that you can look up and determine which state your ions are in if you need to know what type of compound that you need for a solution that you might be making. And this could be important, especially like in nursing, if you're making up a saline solution or something that might be given to a patient. You want to have the right state of the right compounds to go into that mixture. The old naming system uses the us and the ic ending, and so you'll see that the name of the element is going to be converted from like mercury to mercurous or mercuric, depending on the state that it's going to take. But the new naming system, the IUPAC naming system, tries to simplify this and get rid of the us and the ic system, because it was icky. And the new system uses Roman numerals to indicate the charge on the ion. And so this seems to be a much better system to keep track of what state our ion is going to be in. So for copper, for example, copper can either lose one electron or it can lose two electrons depending on what it's reacting with and what type of atom it's forming a bond with. So if copper loses one electron, we would say it's in the copper 1 ionic state. If copper loses 2, we have to say it's copper 2 ion. So for transition metals that can take more than one state, you have to indicate which state they're in by representing the Roman numeral, and then you would follow this by the word ion if you only had that cation present. So our anion naming is a little bit different. The anions are going to be named by replacing the end of the element name with the "ide" ending, and then you would follow this by the word ion. So we've already been talking a lot about sodium chloride, and instead of saying the chlorine ion, I've been calling it the chloride ion, and this is because the anions get the IDE ending, and then you follow this with ion. So bromine in its ionic state would be called the bromide ion. Chlorine would be called the chloride ion. Fluorine would be called the fluoride ion. Iodine, the iodide ion. And oxygen, the oxide ion. And sulfur, the sulfide ion. So you just drop the INE ending and you substitute in IDE, follow that by ion. So we've already talked about the existence of polyatomic ions. Poly means many, and atoms is represented in this word as well. So there are many atoms inside the ion. And so ions that are composed of more than one atom are called polyatomic ions. And these guys are held together by covalent interactions, and so they move as an entire unit. So most polyatomic ions contain oxygen and another element, and their chemical formulas are shown by the subscripts of how many of each type of atom are combined. And for example, the sulfate ion is composed of one sulfur atom and 4 oxygen atoms, and this molecule has a charge of -2. So the entire group of atoms acts as a single unit or a single ion when we're thinking about its use in ionic bonding. So polyatomic ions all move together. So these are some of our common polyatomic ions and their names. And you do not have to memorize their names. You will be given this chart on the test. So you just have to be able to recognize which ion that you have and then correctly use it to make different chemical formulas. So for example, you've got a hydronium ion, you've got ammonium ion. We've already looked at ammonia, and I think we also looked at nitrate, which is over here, the nitrate ion. But you can see that there's a lot of different ions. Most of them are negatively charged when the polyatomic ions occur. And that's just due to the nature of the Earth having so much oxygen present that a lot of these different anions have oxygen in them. So next time we'll talk more about building formulas of ionic compounds.